This video is meant to help you with larger rational functions. We've studied rational functions previously as basic functions as far as proportions go. So similar to this equation over here at the left, where a fraction equals a fraction. And the easiest way to approach that, again, is just to cross multiply. You can easily just take x minus 2, multiply it by x minus 1, which we will have to FOIL together in just a second. And then on the other side, we've got the 6 on the lower left, which is going to get multiplied by x minus 2 on the upper right. And then if we, as I said, FOIL on the left, so x squared minus a 1x on the outside minus 2x inside, so you're going to end up with minus 3x if you add those two middle terms, and a plus 2. And on the right side, a simple distribute. And now that it's quadratic, again, solve for 0. So we're going to add that 12 to the other side, and we're going to subtract 6. So x squared, 3 minus 6 is going to be negative 9. Add 12 is 14. And we would want to decide if we can factor, or if we need to go all the way for the quadratic formula. I think we can get away factoring this one, no. A negative 7 times a negative 2 would be 14. And adding together, they'll give you negative 9, which means x could either be 7 or 2. And then remember to check your answers. Remember, the biggest thing we're looking for is, would either of our numbers make the denominator 0, or do they just flat out not make sides equal? Well, 7 minus 2 is 5/6, and 7 minus 2 on the right side would be 5, and again, 7 minus 1 is 6, so 5/6 equals 5/6 works. And 2 wouldn't make x minus 1 0, but it would make the top of each fraction 0. So 0/6 equals 0 over 1, 0 equals 0. Both answers do end up working. Now the trouble is, on the right side over here, we've got an equation that has 3 different fractions. We could take the time to use a common denominator and add our two fractions together, but there is a faster method. If you can find that common denominator, so looking at 6, 3, and 2x, I'm going to look at all 3 fractions. I believe the least common multiple would be a 6. 2 goes into 6, so does 3, and so does 6. But we also need an x. We want to make sure we cover all of our bases here. So again, that's our least common multiple, right, or least common denominator. But what I'm going to do is not change all of the denominators. Instead, I'm going to multiply both sides completely by that 6x. What that does, remember, is multiplies the top of each fraction by 6x. So we'll end up with 6x over 2x plus 6x times x is 6x squared over 3, and 6x times 7 is 42x over 6. But now the beauty is, if we take a good look at it, 6 divided by 2 is 3, x over x is gone, no more denominator. 3 goes into 6 2 times, x squared sticks around, and again, no more denominator. And 6 goes into 42 7 times, x sticks around, but no more denominator. We get one of our favorite kind of jokes, essentially a one-liner. There's no more denominators in there. And again, it's just quadratic, so 2x squared minus 7x plus 3 equals 0. And then again, you can decide on, would you like to do the quadratic formula, or would you prefer to factor that out? I think we can probably factor it. We just need to end up multiplying the 6, remember, but adding the negative 7. And I think a negative 6 and a negative 1 would work. But don't forget, we need that 2 in front. But if we throw a 3 over here, that will get us that 6 we were looking for, and a negative 1. And I believe that'll end up working for us. If you FOIL that back out, it should end up giving us the correct answer there. Negative 6, negative 1. Yep, just adding to the middle there for half a second. So then set each of those equal to 0 separately. You can imagine, if we kind of cover one of them up at a time, that if I added 1 divided by 2, one of my answers will be 1/2. And the other answer will be 3. And again, if I take those numbers and plug them back in, number one thing I'm looking for is, do either of those numbers make the denominator 0? If not, we're probably okay, and we can leave those alone. Now, if problems get larger, where there's a little more going on, such as this problem here, the same idea works. What you want to remember about the least common denominator is that it has to include the entire quantity that's in the denominator. So because x plus 4 is an addition problem, again, the whole quantity needs to be part of my least common denominator. Same thing goes for x minus 2, and really 3 over 1. There should be a 1 in there as well, but every denominator has a 1. So when we take a look at it, I'm going to use that least common denominator, that LCD, right, of x plus 4 and x minus 2. And I'm going to multiply again, just as I did last time, by the entire right side and the entire left side. So you'll notice I took the fraction on the left. We've still got our 3x plus 15, but I now have an x plus 4x minus 2 in the numerator. And again, our x minus 4, or x plus 4, that was already in the denominator. I'm going to take it on the right side. Don't forget you have to distribute. So 3 times x plus 4x minus 2, and 9 times x plus 4x minus 2, all over x minus 2. The beauty is, again, in your numerator, you've got an x plus 4 and an x plus 4 in the denominator. Here, I'm not going to cancel anything, but on the right side, again, I've got my x minus 2's. So what I can do is eliminate those parts, and now it's a big equation. It's a big, long one-liner, but we just have some simplifying to do. So a little bit of FOIL on the left, FOIL in the middle here, a little distribute on the right. I know that's a lot of terms, but again, if you take a good look at it, we can take x, or 3x squared, subtract it on both sides. You can combine some like terms on each of those sides, and you'll actually end up getting 9x minus 30 equals 15x plus 12. Again, a couple of quick moves, subtracting my 15x, adding my 30, and divide by negative 6, and you'll end up with negative 7. Again, check that answer, but it will end up working. And that's your main idea for large rational functions. Figure out that least common denominator, multiply on both sides. Now, one small recommendation for you when it comes to a problem like that. 3x minus 2 over x minus 2, 6 over x squared minus 4 plus 1. Because this is a quadratic in the denominator, because that's an x squared minus 4, a huge hint is to factor first. X squared minus 4 would technically be x minus 2x plus 2. So when I look for my least common denominator, from the left side I'm going to need an x minus 2. From that second fraction that we just factored the denominator of, I need both an x plus 2 and an x minus 2, but wait, I already have that written down, so I don't need to put another one in there. And then, of course, the one on the right doesn't really have a denominator to worry about. If we take that into account, take x minus 2x plus 2 times all of our parts. Right? On the left, there's the stuff in there, x plus 2x minus 2. In the middle, same thing. And on the right side, then we can cancel away all the stuff in blue. Again, leaving us with a large one-liner. Do some distributing. Add some like terms. And solve our quadratic. Take both answers, plug them back in. Again, make sure that no denominator would turn to 0. 2 would have been a problem. Negative 2 would have been a problem. Neither one of which was one of our solutions anyways. But that's how I would check that answer. I hope that helps you with solving rational equations. If you have any questions about that, make sure you talk to your teacher. Otherwise, good luck and have a great day.